Welcome. Welcome to the office. We want to take a look today at some examples of groups here. Actually, one example maybe and a non-example actually. So let's take a look here. All right, so the following is an example of a group. Now, we talked, I think, in our last lecture about the collection of complex numbers that were of unit length. And I realized that the book actually does give a notation for this particular set. They just use U. So if we say the set U, we're referring to the complex numbers of unit length. Um, so I had denoted it in this way. Now, if we wanted to talk about the nth roots of unity, so unit length, nth roots of unity, we would have u sub n, right? So the cube roots of 1, u3. Fantastic. Anyway, just a quick clarification there. But if we were to take any one of these sets, u or u sub n, and join it with multiplication, our normal multiplication there, this is a group. It's associative, there's no issue there. There is an identity and there are inverses. And we can verify each one of these things. I think that's pretty straightforward. I would encourage you to, well, actually, you know what? Sure. You know what? Let's just do it. Let's verify each of these things. So if I were to consider U, then I can express each of the elements A, B, C in U. Then we can write A as e to the I theta 1, B as e to the I theta 2, and C as e to the I theta 3, right? So we can identify three angle measures, which designate our our complex numbers A, B, and C. Excellent. Of unit length, of course, because our coefficients here are 1 in each case. Now, if I wanted to talk about A multiplied with B multiplied with C, I can observe that this is e to the I theta times theta 1, that is, times e to the I theta 2 times e to the I theta 3, which of course is e to the I theta 1 plus theta 2 times e to the I theta 3. Let's zoom in here. Maybe that'll be a little bit easier to follow along with. I theta 3, which of course is e to the I theta 1. To use parentheses here, theta 1 plus theta 2 plus theta 3. Now, what we want to recognize is that addition of real numbers is also commutative, or rather we would be working in actually R to pi. So if we wanted to, maybe we need to first note that this is, well, we know that's a binary structure. That's fine, but this is actually associative as well. So a lot of times in order to define or observe the associativity of one group, we actually rely on the associativity of another group. In this case, another example, this is also a group. And so we do have that it is associative, which allows me then to say that this is equal to e to the I theta 1 plus theta 2 plus theta 3, which of course we can then show is A times B times C. Now, I shorthanded that work here. Maybe throw a couple of question marks on there. Say, hey, can you fill in those gaps? Because really, to expand it out and then contract it all would take the same amount of steps. So this gives us, right, G1 or A1, the associativity of this particular group and binary operation, or sorry, set and binary operation, right? We don't know it's a group yet. We don't know. Okay, we're looking to verify. So A2, checking for identity, we can notice that 1 belongs to U. Yep, definitely. 1 is a complex number of unit length. That's no problem at all. And A times 1 is equal to 1 times A, which is equal to A. We already know that. We can observe that. There's no problem there. If we wanted to break it down in terms of A can be written in this way, 1 can be written as e to the I times 0. So we get this sort of right additive identity within this. Okay, so that's associated to that. And then a 3, if I wanted to verify inverses, I would notice that I can take 2 pi minus theta 1, and that's in our interval from 0 to 2 pi. And the reason that I would want to do that is because then I can take uh, uh, e to the I theta 1 times e to the I 2 pi minus theta 1, which is equal to e to the 2 pi, I times 2 pi, which of course is under um, working with in here, that's e to the I 0, not theta, e to the I 0, which is just e to the 0. So it's 1. Fantastic. So now I know that e to the 2 pi minus theta 1, sorry, I times that, is the inverse of A. So what I get is I have associativity, I have an identity, and I have inverses for each element. So in this way, I can verify that something is indeed a group. The key here is to make use of the associativity of this group here. Make use of the, right, if I wanted to write the details out of the exponents, I'm making use of the additive identity here. And then similarly here, I'm recognizing that this angle fits within this set of numbers as well. Okay, so really having an understanding of the underlying actions that are being taken. That's definitely good. Take a look at examples from the book that will be very good as well. They'll provide some fantastic examples that will very well supplement what we've discussed here. Now, I want to take a look at something that is not a group, but I feel like this has already been long enough. So really to chunk things up here, I'm going to stop this video. So thank you. Come and join me for a non-example in our next video.